Hi, everybody. It's meteorologist Joe Chaffee. Have the NAM in, have enough of the GFS in, so we can take a look real quick at what's been happening. There hasn't been too much of a change from what started from overnight. So it came up a little, maybe a shade warmer or a shade colder, depending on where you are. So I think I'm going to just kind of leave things the way they are at the moment, and I don't anticipate changing this very much. So this is what I've come up with, and I've leaned on the conservative side of the NAM model, which really is very robust. But here's what I'm doing. So this is my early call, and I will admit my confidence is low. One of the reasons why my confidence is low is that if we're dealing with a low that's redeveloping off the coast, that's always a problem. And especially because when you have a model forecasting it to intensify pretty rapidly over a 24-hour period as it moves by you just to your south and east, that also makes it problematic. Another issue, I was looking at the temperatures aloft are actually not that warm. There's literally as borderline as you can get. So even the most subtle of changes could cause a little bit of dynamic cooling in the atmosphere. That's when basically the atmosphere cools from the top down. Precipitation can cause that. Vertical motion, the lifting of a parcel of air, lifting of moisture from the bottom to the top of the atmosphere can cause some cooling. So these are all things that we're going to be watching very closely here. So right now, what I figured on is that basically as you go, say, south of I-95 or the Route 1 corridor in New Jersey, southeastern PA, mainly rain, extreme southeastern PA, including Trenton and Philadelphia. And then I put this little band in between there and Route 78 where I'm thinking there might be a little bit of snow at the start and there might be a change to snow before it ends. So we'll call that cheap thrill land. And then we go north and west of there with an inch or two possible. I have a tough time figuring out Pennsylvania because I don't know the geography very well. So I could be off on this. There could be a lot of local effects with the mountains that might cause some higher amounts. I'm going to have to look at that a little more closely. I feel more confident when we get up into northeastern Pennsylvania because I do know that area, and northwest New Jersey. So I have that area and mainly north of Route 84, northern Putnam County, Dutchess County, Ulster, Sullivan counties, the potential for at least a few inches, and that extends along and north of Route 84 in Connecticut. And then you go into northwestern Connecticut and into Massachusetts, and we're talking at least 4 to 8. A coating to 2 inches extends south from Route 84 down to about Route 15. So possibly even to 95 or maybe even down to the coast. But let's say, to be safe, Route 15. And that covers most of Westchester County, a chunk of Rockland County, and actually most of Rockland County and just a little bit of Orange County, and that coating to 2. And that goes back. Now, I'm going to tell you right now, I'm being ultra conservative here with regards to the models. I want to gain a sense of confidence. Now, this is the new NAM snowfall map from today's run. And you can see just north and west of the coast how tight it goes from the dark blue, which would be basically a coating, to the lighter blues, which are 3-inch amounts, to the purples, which are basically 5, 6, 7 inches. So, that's a very, very tight gradient here. And it's all going to really hinge on whether the atmosphere cools an extra 1/4 of a degree or not. I mean, that's how fine-tuned we are here. Let me show you what it looks like on the map in terms of the surface, and it's been pretty consistent. There's a low that you can just start to pick out right here in western North Carolina that moves off the Virginia Capes right through here. It's probably a little bit further south with where the wave is. And there's the closed isobar. So this is where the surface low is developing. And then it just starts to deepen or intensify when it's east of Cape May, moves northeast. So the pressure actually drops from about 1,006 millibars on Thursday. I'm sorry. So this would be Thursday at 10 a.m. So from Thursday 10 a.m. it goes from 1,006 to 981 by 10 p.m. So it basically drops almost 20 millibars in a matter of about 12 hours. So that's the 25 millibars. That's a pretty steep deepening rate. And the low continues to intensify as it moves into the Gulf of Maine and beyond. So for interior New England, they're going to get hit pretty hard with this if the NAM is correct. Now, I'll just punch off to the GFS real fast, and I'll show you what the GFS has done, because, again, it continues to have this idea of the wave, but it doesn't develop it as quickly as the NAM does. So as a result, the cold air becomes more of an issue on the GFS. And there's your surface low finally taking over when it's near Cape Cod, and then you got the one low off in the Gulf of Maine. This is long after the precipitation is gone, but it's hitting northern New England quite nicely out of all of this. And that's Thursday night into early Friday morning. So let's look at the GFS snowfall, which is a little less robust. And you can see, because of the fact that it doesn't develop the wave until much later in the period, warm air becomes more important. So the line where we just get a coating of snow gets pushed a little further north and west. So I kind of compromised a little bit with that. And you have the higher amounts, you have to go further north and further northwest in order to get them, and eventually northeast. This is the part where the NAM and the GFS essentially agree. This is the part where they essentially disagree. So the NAM and the European are just pretty much moving in lockstep here. I'll show you what I was saying in terms of how cold it is. We're going to look at the 5,000 foot level, and let me just back this up, and you can kind of see the difference between the two models. So here's the GFS, where the zero line, or the freezing line, is right here, and you kind of see it's bulging toward the coast. You want to be at least -2 at this level, or basically colder than 28 degrees, which would have a good shot at supporting some snow. And then that's just for a short period in the afternoon, and then the cold air comes back in. So I would suspect these areas back here would be changing to snow. The NAM model, on the other hand, because it has the low forming so much quicker, it has a much colder look to it. So the zero line never really gets close. It touches the south shore of Long Island, and then it all collapses. So in this position, I would suspect that much of this area would be mostly frozen precipitation, maybe even into parts of Long Island, if that's the case. As I was looking at the specific numbers of the different layers of the atmosphere, and it's really about as borderline as you get. So, you know what? Jury's still out. Those are my numbers that I showed you. I'll just leave you with that. You can, oops, nope, not that. That's not, I'm going to show you. That's what I want to leave you with. So we'll leave you with this. And, again, my early call, deeper low on the models further south will shift the snow areas southward. My confidence level on all of this at this point is on the low side. So we'll have some more posts up this afternoon, more model discussion. Meteorologist JoeChaffee.com, weatherlongisland.com, and nycweathernow.com for snow-specific forecasts for those areas. Download my app for free, 99 cents for forecasts for New York City, New Jersey, Long Island, Connecticut, Hudson Valley, Eastern Pennsylvania, with corresponding snow maps for each one of those zones. So we'll keep you updated, and we'll see what the European does, which will be out in a little while.